I'm David Ike from Worlds Enough Studios, and in this short video, I want to answer the question, is domain-driven design agile? And of course, the answer is, well, okay, hold on. Maybe we should define our terms. So imagine this. Imagine, instead of your business, you're on a $330 million space project. They're sending a probe to Mars, and your team is writing an important piece of ground control software for it. So you send the analysts over to get the requirements from NASA. They gather those requirements and they pass them on to the software architects. The software architects write the specifications, which they pass on to the engineers, who then write the code to spec. They then pass the code over to the testing engineers and they, test it. Finally, the whole thing gets booted back over the wall to NASA. You and your team get paid and everybody goes home happy. A year or 3 later, NASA sends the probe to Mars, and during the orbital insertion, well, the probe is supposed to aerobrake. It means it skims right through the top of the Martian atmosphere and tries to slow itself down. But there's a problem. Something's wrong, and the probe is entering orbit at just a slightly wrong angle, different than expected. It goes a little too deep into the Martian atmosphere, and all contact is lost. Nobody knows whether it burned up, whether it smashed into the surface, or whether it skipped off into some new orbit around the sun. They can't find it, and nobody knows why. $330 million lost in space. Well, you can understand the bosses at NASA, they're upset about losing all that equipment, and so they started investigating. And lo and behold, the lot falls upon the software module that your team wrote. The module that your team wrote calculated the impulse of the rocket thruster firings in imperial pound-force seconds, while the data that was prepared by a different team was in metric Newton seconds. And if you take Newton seconds and you calculate as if they were pound-force seconds, it doesn't really produce a large error, but it's definitely an error. And it was just large enough to make the angle of the orbital insertion too deep. So the finger pointing begins. The analysts point at the architects and say, we gave them the requirements. Oh, the architects point at the engineers. They implemented it wrong. The engineers just look confused. Nobody specified the units, so we assumed. Everybody points at the testing engineers, but they just shrug. We tested it with the data the engineers gave us. Nobody said anything different. In the end, NASA doesn't blame anybody. They don't blame the contractor at Lockheed, because it turns out that when they received the software at the end, they never bothered to test it either. Oops, our tax dollars at work. This, unfortunately, is a true story. Well, I did make up some of the assumptions about how the process worked, and the finger point at the end, that was all me. But the rest really happened. We really lost a $330 million probe, the Mars Observer, because some software engineers didn't talk to the stakeholders and nail down something as simple as the units to use in thrust calculations. And the stakeholders never bothered to test the final product. They just assumed it worked. And I'd like to tell you that this is just an extreme example, something that rarely ever happens in the real world, but I'd be lying if I did. This sort of thing happens all the time. And most of the time, the stakes are much smaller. Only a few $1 million, or maybe a few $100,000s. Chump change. Chump change that, under the wrong circumstances, in the wrong quarter, can ruin a business. Just search for software project horror stories, and you'll get some reading to really keep you up at night. So it appears there's a pretty common failure mode for software projects, and it's the failure to communicate. It's common enough throughout the industry that a group of 17 prominent software contractors met together at a ski lodge in Utah in the winter of 2001 to talk about it. Now, if you frequented the computer section of a Barnes & Noble in the late 90s like I did, you would have recognized some of their names: Martin Fowler, Kent Beck, and others. Some of them were active in developing new processes for software development. Some you may have heard of, like Scrum. Some you probably haven't heard of, like Crystal or Extreme Programming. Now, if you get 17 opinionated people in a room, many of them competitors, you know it's going to be difficult for them to agree on anything of substance. They were certainly skeptical that anything useful would come out of the conference. But the problem that they were discussing was so large and obvious. Nobody in the process was talking to anybody else in the process. And they also found that their different approaches to the problem had equally broad similarities. They hit upon a common word to describe their vision for how software development should proceed: Agile. The product of their conference was a document called the Agile Manifesto. Now, the interesting thing about the Agile Manifesto is that it doesn't talk much about the software itself, except to say that the software should work and be of excellent quality. Here's a value statement from the Agile Manifesto. We are uncovering better ways of developing software by doing it and helping others to do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. Individuals and interactions, working software, customer collaboration, responding to change. That's all about communication. They elaborated on all that in 12 principles. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. We welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. Delivering working software frequently from a couple of weeks to a couple of months, with a preference to the shorter timescale. Business people and developers must work together daily throughout the project. Build projects around motivated individuals. Give them the environment and support they need, and trust them to get the job done. The most efficient and effective method of conveying information to and within a development team is face-to-face conversation. Working software is the primary measure of progress. Agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. Continuous attention to technical excellence and good design enhances agility. Simplicity, the art of maximizing the amount of work not done, is essential. The best architectures, requirements, and designs emerge from self-organizing teams. At regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. Now, I started out this video by talking about domain-driven design and asking if it was agile. And of course, the answer is yes, of course it is. As I mentioned in my last video, Agile tells us that software engineers should talk to subject matter experts directly and often. Domain-driven design simply expands on that, specifying what they should talk about and how to develop a common, ubiquitous language between the engineers and the experts so that there are no misunderstandings along the way. Then, yes, it presents a bunch of patterns that the engineers can use, that they can get working software stood up quickly, using designs that can be adapted to changing requirements as needed. Again, agile, very agile. But the important part from your perspective is the communication angle. To avoid the common failure mode of so many software projects, you really must set up these meetings and give the engineers regular, even daily access to yourself and your business experts. Now, yes, that is an extra cost, invaluable time and money. But you have to ask yourself, do I want working software that actually meets my business's needs, that gives me a competitive advantage? Or, put another way, can you afford to pay money for software that doesn't work? So, we've talked about the origins of the term Agile, and we talked a bit about how domain-driven design applies the Agile principles in practice. This all sounds great, right? But as some of the manifesto signatories admitted, it's a bit mushy. So, how is this actually supposed to counter the problems of poor communication? What does it look like in practice? So let's go back to our Mars probe as an example. In an Agile approach, the engineers would have been present in the very first meeting with NASA, and they would have demanded there be a subject matter expert, a rocket scientist, in the room too. Using domain-driven design principles, they would have asked questions until they understood the problem and had a common language to speak with the rocket scientists. And this is the first meeting, 2-3 meetings. Then they would have developed a plan to get some piece of the larger system working within a few weeks. They would have met regularly with the rocket scientists throughout those first few weeks, ideally daily, to ask questions as they came up, again, using that common language to avoid misunderstandings. Then, as soon as they had something working, they would have demonstrated it to the rocket scientists, using data provided by the rocket scientists. Now, because there was another team involved too, the team providing the actual data, they would have insisted upon meeting with them too, with the rocket scientists in the room, to make sure that everybody was working toward a common goal and using agreed upon language. And as an inevitable part of all this intentional communication, the wrong assumptions about thrust units would have come up early. After all, the units used in the calculations would have been an important part of the ubiquitous language. Everybody would agree, yes, let's use metric. And because of that simple agreement, we would have a Mars observer orbiting the red planet today, sending back valuable scientific data. The solution really is that simple. I hope that helps answer some of your questions about just what Agile and domain-driven design really mean. If it has, I just ask that you hit the like button down below the video, and I'd really appreciate it. Beyond that, if you want to learn more about domain-driven design and how it can make your business more efficient through better software, you'll also want to hit the subscribe button below. In my next few videos, I'll be going through this book, Domain-Driven Design, the original Blue Book by Eric Evans. I'll be going through it at a pretty high level and calling out the important things for your business. Basically, I'm reading it so that you don't have to, because it's pretty thick. I really do think that the principles in this book can improve how you develop custom software for your business. And if you understand these principles and implement them in your next software project, you'll truly be able to use custom software to lower your expenses, increase your revenues, and get you that competitive advantage that you really need. If you want to hear all that, please do hit the subscribe button below and that little notification bell too, so you won't miss any of it. Thank you for spending some time with me, and I do hope it's been helpful. Once again, I'm David Icke with Worlds Enough Studios. God bless you, and I'll see you next time.